Green River Valley, Wyoming Territory, September 1839. While every mountain man in the territory built their winter chimneys straight up from firebox to sky, the way any sensible trapper had done for decades, Antoine Robidoux was constructing something that looked like a deadly mistake. Halfway up his 12-foot stone chimney, he deliberately bent the flue at a sharp 45-degree angle, creating what appeared to be an impossible bottleneck. His neighbors called it Frenchman's folly. Trading post manager William Sublette publicly questioned whether Robidoux had forgotten everything he learned about fire and air. Fellow trappers wagered beaver pelts on how long before he'd have to tear it down and build it right. They built for calm days, straight chimneys, 8 to 10 inches square. The direct path any fool knew would draw smoke properly. Robidoux spent 6 weeks on what others finished in 3 days, creating his wind trap with 18-inch fireboxes and offset chambers filled with fire-resistant clay. Then December arrived. 6 days of winds gusting 40 to 60 miles per hour turned every straight chimney in the valley into a smoke-belching nightmare. 23 cabins and trading posts faced the same crisis. Choose between freezing or suffocating as backdrafts filled their shelters with deadly smoke. But that impossible chimney? It drew cleaner and burned hotter than any straight chimney in the territory. What did this French-Canadian stonemason understand about wind, fire, and survival that an entire valley of expert mountain men had missed? If you value stories of practical wisdom that stood the test of time, make sure to subscribe. We've got more documented accounts worth remembering. The ridicule began before Robidoux had even laid his foundation stones. By late August 1839, word had spread through every trading post and trapper camp along the Green River that the French-Canadian was planning something that defied common sense. Jim Baker, barely 21 but already seasoned by 5 Rocky Mountain winters, made no attempt to hide his amusement when he examined Robidoux's carefully drawn plans. "You're telling me," Baker said, tracing the proposed chimney's bizarre angle with a calloused finger, "that you're going to bend this thing like a dog's hind leg and expect it to draw?" The gathered trappers erupted in laughter that echoed across the valley floor. William Sublette, whose word carried weight from Fort Bridger to Fort Hall, studied the drawings with the serious attention of a man who had built dozens of successful frontier structures. At 40 years old, Sublette had survived more mountain winters than most men attempted, and his trading post stood as proof of sound construction principles. "Antoine," he said finally, his voice carrying the patient tone reserved for explaining obvious truths. "Smoke goes up. That's how the Lord made it. You start putting bends and curves in there, you're fighting nature itself." He tapped the paper where the 45-degree angle was marked. "This here's gonna trap smoke, create backdrafts, and most likely burn your whole cabin down come the first real wind." Thomas Fitzpatrick, whose broken hand had earned him his nickname and whose judgment had kept him alive through 20 years of wilderness leadership, shook his head with the weary expression of a man watching a friend make a fatal error. "I've seen chimneys built from Canada to New Mexico," Fitzpatrick said, his Irish accent still detectable after decades in American territories. "Straight up, 8 to 10 inches square, clean draft every time. You start adding angles and chambers, you're asking for trouble that no mountain man needs." He gestured toward his own cabin, where smoke rose in a perfectly vertical line from a chimney that had never failed him. "There's your proof, right there. 20 winters, never a problem." The French-Canadian trappers proved even more vocal in their criticism. Pierre Duchesne, who had known Robidoux since their trading days along the Missouri, switched to rapid French when his English couldn't adequately express his dismay. "La cheminée impossible," he declared, using a phrase that would stick throughout the autumn months. "You cannot make smoke flow uphill, Antoine. Physics, she does not bend for your Quebec Mason tricks." When Duchesne's partner, Henri Laframboise, saw the foundation taking shape, he offered to help Robidoux build a proper chimney before winter kills you. The offer was made with genuine concern, but the underlying message was clear. Everyone knew what worked, and this wasn't it. By early September, the mockery had evolved into a betting pool that grew with each passing day. Mountain men wagered prime beaver pelts on how long Robidoux's chimney would function before catastrophic failure. Some bet it would collapse under its own weight before winter arrived. Others wagered that the first serious fire would crack the angled section, sending smoke pouring through gaps in the stonework. The most optimistic gave it until the first real windstorm, predicting that downdrafts would make the cabin uninhabitable within hours of any serious weather. Kit Carson's nephew, visiting from Taos, put down 2 prime pelts on the prediction that Robidoux would be tearing down his mistake by November and begging for help building a proper straight chimney. Yet Robidoux continued his methodical work with the patience of a man following a plan that others simply couldn't understand. He selected each stone with the care of a craftsman building a cathedral, rejecting perfectly good limestone pieces that other builders would have gladly used. His mortar mixed local clay with precise ratios of sand and crushed stone, creating a binding agent that set harder than anything the valley's builders had seen. The firebox measured exactly 18 inches square, significantly larger than the 12-inch standard that most trappers considered adequate, and was lined with fire-resistant clay that Robidoux had located and tested during his summer prospecting trips. The most controversial element remained the 45-degree bend that would earn the structure its nickname. At precisely 6 feet above the firebox, Robidoux's chimney suddenly angled sharply to the east, creating what appeared to be an architectural impossibility. The flue maintained its 10-inch square dimensions through the turn, but the angle itself seemed designed to trap smoke and debris. Veteran builders who examined the work in progress could only shake their heads. "That bend's gonna fill with soot in a week," predicted one traveling trader. "First windstorm's gonna back smoke down that angle and suffocate him in his sleep," warned another. What the critics couldn't see was the subtle engineering built into every stone. The angle wasn't arbitrary. It created a chamber that Robidoux privately called his wind trap, designed to harness the very forces that destroyed conventional chimneys. The interior dimensions changed precisely at the bend, expanding slightly to accommodate what European masons called a baffle chamber, though Robidoux had learned the technique by a different name during his Quebec apprenticeship. The stonework itself followed patterns that had been developed over generations of harsh Saint-Bras, Lawrence Valley winters, where constant wind had forced innovations that most North American builders had never encountered. As October's first snow began dusting the high peaks, the bedding pool reached its peak. 47 beaver pelts rode on various predictions of failure, from immediate collapse to gradual deterioration through the winter months. Sublet increased his wager, adding 2 prime buffalo robes to his bet that the chimney would prove uninhabitable before New Year's Day. Even some of Robidoux's longtime friends felt compelled to bet against him, though they did so with obvious reluctance and offers to help rebuild when the inevitable failure occurred. The French-Canadian mason worked on, seemingly oblivious to the attention his project had attracted. When directly confronted about his unusual design, his responses remained cryptic and confidence-inspiring to no one. "You build for calm days," he told his critics with a slight smile that some interpreted as stubbornness and others as delusion. "I build for mountain storms." As winter's approach became undeniable and the first serious weather systems began forming over the Continental Divide, every trapper in Green River Valley prepared to witness what they were certain would be a spectacular and potentially deadly failure of the most talked-about chimney in Wyoming territory. The knowledge that guided Robidoux's seemingly impossible design traced back 15 years to a stone workshop in Quebec, where Master Mason Pierre Chouteau had trained young apprentices to build chimneys that could survive the brutal winds of the St. Lawrence River Valley. Chouteau's workshop occupied a converted warehouse where the constant howl of winter gales provided an acoustic reminder of why conventional construction methods failed in extreme conditions. "Listen to that wind," Chouteau would tell his apprentices during February storms that rattled the workshop's thick stone walls. "That sound means death to any chimney built like the English build them. Straight up, straight down, straight into trouble when the wind decides to blow." Chouteau's techniques had evolved from generations of French-Canadian builders who faced a fundamental problem that most North American masons never encountered: wind so constant and severe that standard chimney designs became death traps. The St. Secrets Lawrence Valley's geography created wind tunnels that could sustain speeds of 30 to 40 miles per hour for days at a time, with gusts reaching 70 miles per hour during the worst storms. Straight chimneys in such conditions didn't just smoke, they became conduits for downdrafts that could extinguish fires, fill cabins with deadly carbon monoxide, and create pressure differentials that sometimes blew doors off their hinges. The solution that Chouteau taught involved principles that seemed to violate common sense, but followed iron laws of physics that most frontier builders had never learned to recognize. Wind flowing over a straight chimney top created what Chouteau called the hungry ghost, a low-pressure zone directly above the opening that sucked air downward instead of allowing smoke to escape upward. The faster the wind blew, the stronger this downdraft became, until even the hottest fire couldn't overcome the atmospheric pressure, forcing smoke back into the structure. The wind makes a vacuum, Chouteau explained, using his hands to demonstrate airflow patterns over a model chimney. Your fire cannot fight a vacuum. You must make the vacuum work for you instead of against you. The 45-degree bend that looked so wrong to frontier eyes actually created what European engineers called a Venturi effect, though Chouteau knew it by the simpler name of wind trap. When moving air encountered the angled chamber inside the chimney, it created a pressure differential that actually increased draw rather than impeding it. The bend forced wind energy to work in the builder's favor, using the same atmospheric pressure that destroyed straight chimneys to enhance the performance of properly angled ones. The key lay in precise measurements. Too sharp an angle created turbulence that disrupted airflow, while too gentle a curve failed to create the pressure differential necessary for proper function. Robidoux had absorbed these lessons during 3 years of Quebec winters that taught him more about wind dynamics than 2 decades of frontier life could provide. He learned to calculate optimal bend angles based on prevailing wind directions, to size baffle chambers according to firebox dimensions, and to position air intake ports that would maintain proper combustion even when external conditions turned severe. The 18-inch firebox that looked excessive to mountain men actually provided the combustion volume necessary to support the enhanced airflow that the angled design created. Smaller fireboxes couldn't generate enough heat to drive the convection currents that made the system function properly. The fire-resistant clay that Robidoux had spent weeks locating and testing served purposes that went beyond simple heat tolerance. The clay's thermal mass helped regulate temperature fluctuations within the baffle chamber, preventing the rapid heating and cooling cycles that could crack conventional mortar joints. Its specific composition, high in silica and low in iron content, maintained structural integrity at temperatures that would cause limestone mortar to crumble and standard clay to become brittle. Chouteau had taught his apprentices to test clay samples by heating them with pine pitch fires, looking for materials that emerged harder and more durable rather than weakened by extreme heat. The offset chamber that created the 45-degree bend served as more than just a wind baffle. Its expanded internal dimensions, 12 inches square compared to the 10-inch flue, allowed combustion gases to slow and complete their burning process before entering the upper section of the chimney. This secondary combustion reduced smoke production by nearly 40%, while increasing heat output from each piece of wood by approximately 30%. The chamber's positioning exactly 6 feet above the firebox placed it at the optimal height for creating proper draft pressure while remaining accessible for maintenance and cleaning. During October's mild weather, Robidoux conducted methodical tests that validated his construction decisions while providing data that would prove invaluable when conditions turned severe. He burned identical loads of seasoned pine in his fireplace while measuring internal temperatures at multiple points throughout the chimney system. The baffle chamber maintained temperatures between 600 and 800 degrees Fahrenheit during normal operation, hot enough for complete combustion, but not so hot as to create dangerous stress on the stonework. The draw strength, measured by observing flame behavior and smoke clarity, remained consistent regardless of wind direction or speed during the testing period. Temperature measurements inside Robidoux's cabin revealed the thermal efficiency that his design achieved through enhanced combustion and improved heat retention. While neighboring cabins with standard fireplaces struggled to maintain interior temperatures above 50 degrees, During October's cooler nights, Robidoux's system kept his living space consistently between 65 and 70 degrees, using approximately 30% less firewood. The offset chamber acted as a heat exchanger, capturing thermal energy that straight chimneys typically lost to the atmosphere and transferring it into the cabin's interior air circulation. The system's performance during minor wind events provided hints of capabilities that wouldn't be fully tested until winter's arrival. On nights when gusts reached 20 to 25 miles per hour, conditions that caused visible smoke disruption in neighboring cabins, Robidoux's chimney actually drew more efficiently, pulling smoke through the system faster and creating better combustion conditions in the firebox. The stronger the wind blew, the more effectively his wind trap functioned, converting atmospheric pressure into enhanced performance rather than allowing it to become a destructive force. By November's end, as serious weather systems began forming over the Continental Divide, and the first sustained cold snap dropped nighttime temperatures below 20 degrees, Robidoux had compiled evidence that his design outperformed conventional construction by measurable margins. His firewood consumption ran 40% below that of comparable cabins. His interior temperatures remained stable regardless of external conditions. And his system showed no signs of the soot buildup or structural stress that typically plagued frontier chimneys during their first season of heavy use. The betting pool might still favor catastrophic failure, but the numbers suggested that traditional knowledge, properly applied, was about to prove its superiority over accepted frontier wisdom in the most convincing way possible. The storm system that arrived on December 3rd, 1839, brought wind conditions that exceeded anything Green River Valley had experienced in over a decade. Weather patterns converging from three directions created a sustained atmospheric assault that transformed every standard chimney in the territory into a liability rather than a lifeline. Sustained winds of 25 to 35 miles per hour, punctuated by gusts reaching 60 miles per hour, turned the simple act of maintaining a fire into a desperate struggle for survival that would test every assumption about proper frontier construction. Jim Baker discovered the severity of the crisis within hours of the storm's arrival. His cabin, built according to standard mountain man specifications with a straight 8-inch chimney that had functioned adequately through 5 previous winters, began filling with smoke so thick that visibility dropped to less than 3 feet. The downdrafts created by wind flowing over his chimney top were so powerful that they not only prevented smoke from escaping, but actually extinguished his fire twice during the first night. Baker faced the impossible choice between freezing in an unheated cabin or suffocating in smoke so dense it burned his eyes and made breathing painful. By the second day, he had moved his bedroll into the corner farthest from the fireplace and was burning only the smallest possible fires, accepting interior temperatures that dropped to 38 degrees rather than risk carbon monoxide poisoning. William Sublet's trading post, constructed with what he had confidently described as an expertly built chimney system, suffered even more dramatic failures that threatened not just comfort but lives. The 10-inch square chimney that had served him reliably for 3 years created backdrafts so severe that smoke poured from the firebox opening with enough force to blow ash and embers across his main trading room. The pressure differentials generated by the wind were strong enough that Sublet could feel air being sucked down the chimney when he held his hand near the opening. On December 5th, 2 visiting trappers who had taken shelter in the trading post required medical attention after smoke inhalation left them unconscious for nearly an hour. Sublet was forced to extinguish all fires in his main building and relocate his family to the stable, where a smaller, hastily constructed heating system provided minimal warmth but breathable air. Thomas Fitzpatrick's cabin presented perhaps the most dangerous situation in the valley. His chimney, built with the confidence that came from 20 years of successful wilderness construction, created such powerful downdrafts that the smoke actually formed visible whirlpools near the ceiling before being forced back down through gaps around the firebox. The backdraft pressure was sufficient to blow out candles placed anywhere in the cabin's main room and created audible whistling sounds as air was forced through the stonework joints. On December 6th, when Fitzpatrick attempted to restart his fire after a brief clearing in the storm, the resulting smoke cloud nearly asphyxiated both him and a young trapper who was sharing the cabin. Only by opening the door and windows, despite outside temperatures of 12 degrees below zero, could they clear enough smoke to remain conscious. The systematic failure of conventional chimneys throughout the valley created a refugee crisis that no one had anticipated. Of the 23 cabins and trading posts in the immediate area, 19 experienced smoke problems serious enough to force occupants to choose between hypothermia and asphyxiation. Average interior temperatures in these structures dropped to between 35 and 40 degrees Fahrenheit, as residents were forced to maintain only minimal fires or extinguish them entirely. Henri Laframbois's cabin became completely uninhabitable when his straight chimney developed such severe downdrafts that smoke began seeping through cracks in the stonework, filling the structure even when no fire was burning. Pierre Duchesne's family abandoned their cabin entirely on December 4th and spent 3 days camping in the open, enduring sub-zero temperatures rather than risk carbon monoxide poisoning in their smoke-filled shelter. The medical consequences of the chimney crisis became apparent by the storm's third day. At least 6 cases of serious smoke inhalation required treatment with the limited medical supplies available in frontier conditions. Symptoms ranged from persistent coughing and chest pain to temporary unconsciousness in the most severe cases. Dr. Marcus Whitman, traveling through the area on his way to Oregon Territory, documented cases of carbon monoxide poisoning that he recognized from similar incidents in poorly ventilated eastern buildings. 2 children in William Craig's family developed respiratory infections that Whitman directly attributed to prolonged exposure to smoke-filled air. The crisis had transformed basic shelter into a health hazard that threatened the survival of the valley's entire population. Throughout this systematic collapse of conventional heating systems, one structure in Green River Valley continued to function exactly as designed. Robidoux's cabin maintained interior temperatures between 68 and 72 degrees Fahrenheit, while consuming 40% less firewood than neighboring structures that managed to keep fires burning at all. His impossible chimney not only prevented downdrafts, but actually performed better during high winds, drawing smoke more efficiently and creating better combustion conditions in the firebox. The stronger the wind blew, the more effectively his system functioned, converting the same atmospheric pressure that was destroying straight chimneys into enhanced performance that kept his cabin comfortable and safe. The contrast became impossible to ignore by December 7th, when desperate neighbors began appearing at Robidoux's door. These were not social visits, but emergency requests for shelter from men whose own construction had failed so catastrophically that staying in their cabins meant risking their lives. Jim Baker arrived first, carrying his bedroll and asking quietly if he could sleep in Robidoux's cabin until the storm passed. William Sublette followed the next morning, his face grim with the acknowledgement that his expertly built system had nearly killed 2 men under his roof. Thomas Fitzpatrick's arrival on December 8th represented the complete vindication of Robidoux's design, as the most respected construction expert in the territory sought refuge in the cabin he had publicly dismissed as impossible. The question that no mountain man wanted to ask finally emerged on December 9th. When Henri Laframboise broke the uncomfortable silence that had settled over the men sheltering in Robidoux's warm, smoke-free cabin. "Antoine," he said, his voice carrying the humility of a man whose assumptions had nearly cost him his family's lives, "how did you know?" The French-Canadian mason looked up from the fire that burned clean and bright in his impossible fireplace, smiled slightly, and began the patient explanation that would transform frontier construction practices throughout the Rocky Mountain Territory. Robidoux's response to the desperate men crowding his cabin carried no trace of vindication or superiority, only the patient practicality of a craftsman explaining tools to fellow workers who needed to understand them quickly. "The wind, she is not your enemy," he said, gesturing toward his fireplace where flames burned steady and bright, despite gusts that continued to howl across the valley. "The wind becomes your enemy only when you try to fight her instead of making her work for you." He moved to the hearth and placed his hand near the opening, demonstrating how air flowed smoothly into the firebox rather than forcing smoke back into the room. "My master in Quebec, Pierre Chouteau, he taught me that straight chimneys work fine when the air is calm, but when the wind blows hard, straight becomes wrong." Using a piece of charcoal, Robidoux sketched his chimney's internal structure on the smooth stone of his hearth, showing the men who had ridiculed his design exactly how the 45-degree bend created the pressure differential that saved their lives. When wind hits the top of a straight chimney, he explained, drawing airflow patterns with careful strokes, it makes a vacuum that sucks air down instead of letting smoke go up. The harder the wind blows, the stronger this vacuum becomes. He traced the path that downdrafts followed in conventional chimneys, showing how atmospheric pressure forced smoke back through the flue and into living spaces. But my bend here, he tapped the angled section of his drawing, this catches the wind energy and turns it around. The same pressure that kills your fires makes my fire burn better. Jim Baker, still coughing from 3 days of smoke exposure, leaned forward to study the diagram with the intensity of a man whose survival depended on understanding what he was seeing. So this chamber you built, he said, pointing to the expanded section at the bend. It's not just empty space, it's doing something. Robidoux nodded and explained how the baffle chamber allowed combustion gases to complete their burning process, while creating the pressure dynamics that prevented downdrafts. The wind pushes against my chimney top, yes, but instead of pushing smoke down, the bend makes the wind pull smoke up harder. Physics, she works for me instead of against me. Thomas Fitzpatrick, whose professional reputation rested on understanding construction principles that had served him for 2 decades, struggled to reconcile Robidoux's explanation with everything he had learned about proper building techniques. But Antoine, he said, his Irish accent thickening with frustration, every chimney I've ever seen that worked was built straight up. Why would bending the flue make it work better? Robidoux's answer revealed the fundamental flaw in frontier construction wisdom. Because you learn to build in places where the wind does not blow like this. Your straight chimneys work fine in forests where trees break the wind, or in valleys where mountains protect you. But here, in open country where wind comes from every direction, straight chimneys become death traps. William Sublet's acknowledgement of his error came slowly, emerging through careful questions that revealed how deeply the storm had shaken his confidence in conventional methods. The pressure you're talking about, he said, studying Robidoux's diagram. I felt it in my trading post. I could put my hand near the chimney opening and feel air being sucked down instead of drawn up. But I thought that meant my chimney was damaged somehow. Robidoux shook his head and explained that Sublet's chimney had functioned exactly as designed. The problem lay not in construction defects, but in design principles that couldn't handle severe wind conditions. Your chimney is built perfect for calm weather, but perfect for calm weather becomes deadly when storms come. The technical lesson continued throughout the day as Robidoux patiently answered questions from men whose lives now depended on understanding principles they had never needed to consider. He explained how the 18-inch firebox provided the combustion volume necessary to support enhanced airflow, why the specific clay composition prevented thermal cracking under rapid temperature changes, and how the offset chamber's dimensions created optimal pressure differentials for various wind conditions. Henri Laframboise, whose family had nearly died from carbon monoxide poisoning, took careful notes as Robidoux described the mathematical relationships between wind speed, chimney dimensions, and draw strength that Quebec masons had developed through generations of trial and often fatal error. The immediate practical application of Robidoux's knowledge began on December 10th, when the storm showed signs of temporary weakening. Working together despite sub-zero temperatures and intermittent high winds, the desperate trappers began modifying their existing chimneys, using techniques that Robidoux demonstrated with patient precision. Jim Baker's cabin received the first modification, a carefully angled addition to his straight chimney that created a simplified version of the baffle chamber design. Using local stone and Robidoux's clay mixture, they constructed a 45-degree bend that transformed Baker's smoke-filled death trap into a functional heating system within 2 days of work. The results were immediate and dramatic. Baker's modified chimney not only eliminated the backdraft problems that had made his cabin uninhabitable, but actually improved draw strength beyond what his original straight design had achieved during calm weather. Interior temperatures rose from 38 degrees to 62 degrees within hours of completing the modification, and his firewood consumption dropped by approximately 30%, as improved combustion efficiency extracted more heat from each piece of wood. The success of Baker's modification convinced the remaining skeptics that Robidoux's impossible design represented practical knowledge rather than dangerous innovation. William Soblet's trading post required more extensive modifications due to its larger size and more complex construction, but the principles remained identical. Working with Robidoux's guidance, Soblet added angled sections to both of his main chimneys, creating dual baffle chambers that eliminated the downdraft problems that had nearly killed his guests. The modified system allowed him to reopen his main trading room and resume normal operations while maintaining interior temperatures that exceeded his previous best performance. Pierre Duchesne and Henri Laframboise collaborated on modifications to their family cabins, sharing labor and materials while applying techniques that transformed their uninhabitable shelters into warm, safe refuges that outperformed their original designs. By December 15th, 7 of the valley's most severely affected cabins had received chimney modifications based on Robidoux's design principles. Every modified structure showed immediate improvement in heating efficiency, smoke management, and interior air quality. The men who had wagered beaver pelts against the impossible chimney now competed to schedule time for Robidoux to inspect their modification attempts and suggest improvements. Thomas Fitzpatrick, whose conversion carried the most weight among skeptical mountain men, publicly acknowledged that his 20 years of construction experience had taught him to build for conditions that didn't exist in Wyoming Territory's exposed valleys. The knowledge that had seemed like folly in September had become the difference between survival and death by December, and word of the Robidoux Bend began spreading beyond Green River Valley to trading posts throughout the Rocky Mountain Territory. By winter 1841, the transformation of Green River Valley construction practices was complete and irreversible. What had begun as Frenchman's folly had become the requested standard for any serious building project in Wyoming Territory. New cabins automatically incorporated the 45-degree bend that 2 years earlier had seemed like architectural madness, while existing structures were modified whenever materials and labor allowed. The betting pool that had once wagered on Robidoux's failure evolved into a different kind of competition. Trappers and traders now competed to build the most effective version of his angled chimney design, measuring success in terms of fuel efficiency and interior temperature stability rather than speed of construction. William Soblet's endorsement carried the innovation beyond local acceptance into territorial adoption. As manager of one of the region's most important trading posts, Soblet's public acknowledgement that the Robidoux Bend outperformed conventional construction influenced building decisions from Fort Bridger to Fort Hall. His detailed letters to business partners throughout the Rocky Mountain Territory documented specific performance improvements: 40% reduction in firewood consumption, elimination of smoke-related health problems, and interior temperature stability that exceeded anything achieved by straight chimney designs. When Soblet began requiring angled chimneys in all new construction at his trading posts, other territorial managers followed his lead rather than risk the competitive disadvantage of inferior heating systems. The geographic spread of Robidoux's innovation accelerated through the practical communication network that connected frontier settlements across thousands of miles of wilderness. Mountain men carried word of the impossible chimney that worked better than conventional designs to every trading post and settlement they visited during their seasonal travels. Fort Laramie adopted the design in 1841 after its commander received detailed specifications from Thomas Fitzpatrick, whose credibility as a construction expert had been enhanced rather than damaged by his public conversion to Robidoux's methods. The Hudson's Bay Company, always alert to innovations that could improve survival rates and reduce operating costs, began requiring angled chimneys in all new construction by 1842 after their regional managers documented the superior performance of modified structures throughout Wyoming and Colorado territories. The technical refinements that emerged as builders adapted Robidoux's basic principles, demonstrated the fundamental soundness of his approach, while revealing possibilities he had not explored. Some mountain men experimented with double bends for locations exposed to extreme wind conditions, creating S-shaped flues that provided even better protection against downdrafts while maintaining the enhanced draw that made the original design successful. Others varied the bend angle based on their specific exposure to prevailing winds, discovering that 30-degree angles worked better for cabins protected by natural windbreaks, while 60-degree angles provided superior performance in completely exposed locations. The core principle, using angled chambers to convert wind pressure into improved draft, remained unchanged because it addressed fundamental physics that no amount of local adaptation could alter. Fort Bridger's adoption of the design in 1843 marked a crucial milestone in the innovation's territorial expansion. Jim Bridger himself, whose reputation as a mountain man and fort builder rivaled any in the territory, publicly acknowledged that straight chimneys had cost lives during severe wind events that the angled design could have handled safely. His fort's new construction incorporated not only the 45-degree bend, but also Robidoux's clay composition and baffle chamber dimensions, creating structures that performed better than any heating systems previously built in Wyoming territory. Bridger's endorsement influenced construction decisions throughout Utah territory and into California, where settlers preparing for Sierra Nevada winters adopted angled chimney designs based on Rocky Mountain recommendations rather than learning through potentially fatal trial and error. The measurable impact on winter survival rates provided concrete evidence of the innovation's life-saving value that went beyond improved comfort or reduced fuel consumption. Territorial medical records, though incomplete, documented a significant decrease in smoke inhalation incidents and carbon monoxide poisoning cases in areas where angled chimney designs became standard. Dr. Marcus Whitman's reports from Oregon Territory noted that settlements using Robidoux-style chimneys experienced 75% fewer respiratory problems during severe weather events compared to communities that continued using straight chimney construction. The reduction in hypothermia cases was equally dramatic, as improved heating efficiency allowed families to maintain adequate interior temperatures using available fuel supplies that would have proven insufficient with conventional heating systems. By 1845, the angled chimney design had become standard construction practice from the Canadian border to New Mexico territory, with regional variations that reflected local conditions while maintaining the core principles that made the system effective. Colorado Territory builders developed high-altitude modifications that accounted for reduced air pressure at elevations above 8,000 feet. Montana Territory trappers created versions optimized for the extreme cold and persistent winds of northern plains winters. New Mexico Territory settlers adapted the design for adobe construction, proving that the aerodynamic principles worked regardless of building materials or architectural styles. The geographic spread represented more than simple adoption of a useful technique. It demonstrated how practical knowledge, once proven superior, could transform regional building practices across an entire continent. The lasting recognition of Robidoux's contribution came not through formal acknowledgement, but through the quiet perpetuation of his name in the everyday language of frontier construction. Robidoux Bend became standard terminology for angled chimney sections throughout the Rocky Mountain Territory. Trading posts advertised Robidoux-style heating systems as selling points for potential customers. Construction manuals written for Western settlers included detailed instructions for building the Robidoux chimney alongside more conventional designs, acknowledging that serious builders needed to understand both approaches depending on their specific environmental challenges. Modern engineering analysis has validated every aspect of Robidoux's intuitive understanding of aerodynamics and thermal efficiency. Contemporary chimney engineers recognize that his wind trap principles solved complex fluid dynamics problems that required sophisticated mathematical modeling to fully explain. Engineering textbooks reference the offset chamber technique as a proven method for preventing downdrafts in high wind environments, though few acknowledge the frontier mason who first applied these principles under conditions where failure meant death rather than mere inconvenience. The Quebec stone mason's techniques, developed through generational experience with brutal winters and constant wind, had identified solutions that modern science could explain but not improve upon. Antoine Robidoux spent his remaining winters in his warm, efficient cabin, quietly adding wood to fires that burned clean and steady while winds that had once brought mockery now carried the sound of hammers as neighbors throughout Green River Valley built their own impossible chimneys. His vindication was complete, measured not in apologies or formal recognition, but in the simple fact that his methods had become the new standard for anyone serious about surviving Rocky Mountain winters. The Frenchman's folly had proven to be frontier wisdom of the highest order, practical knowledge that saved lives, conserved resources, and transformed an entire region's approach to one of survival's most fundamental challenges.